we could augment equation 1, which is this part of the equation, by adding control variables. Remember that this t, it's either 0 if individual I did not receive treatment, and it's equal to 1 if individual I received treatment. And these control variables are either, or they are, variables measured at baseline at time t equals 0, and they are either constant over time, or they are not constant over time, like age. One reason why we would include such control variables is that even if they are not correlated with the treatment group, so the correlation between the treatment variable and the control variable, it should be 0, because we have chosen the treatment randomly. So we have, from our random or simple random sample, we have randomly assigned individuals to either the treatment group or the control group, which means that there should be absolutely no omitted variable bias in our estimate of the causal effect. But if the betas on the control variables are different from 0, then they are relevant in explaining variation in the outcome, the y variable, and as such they cause the variance of the regression, the variance of the residuals, to fall, which means that the standard error of the slope on the treatment falls as well, which means that we get a more precise estimate of the causal effect. If randomization was based on covariates, which means variables which we can measure, then adding control variables would be quite necessary. So in our example, suppose that randomization was conducted in such a way that old people had an 80% probability of getting the treatment, but young people had a 40% probability of getting the treatment. So now there is a difference in probability between old people and young people of getting the treatment. So the treatment variable is correlated with the age variable, and if we do not include the age variable in our regression, then our beta, or the causal effect, the estimate of beta 1, would be correlated with the error term. And if our variable, our treatment variable, is correlated with the error term, then we would get a biased estimate of the beta. But it's quite simple to avoid this bias. It's just to include the relevant variable in our equation as a control variable.